Hello guys, welcome back. So today's subject is about electronic principles and circuits, and the topic is about Class A push-pull amplifier. A Class A push-pull amplifier circuit is as shown below. By Class A push-pull amplifier means that current flows in the output of the active device for the entire of the input cycle. So the circuit arrangement is the circuit of the typical Class A push-pull amplifier is shown in the figure. As already mentioned, push-pull amplifier uses two identical transistors, let's say Q1 and Q2. The emitter terminals of the two transistors Q1 and Q2 are connected together. The input signals is applied to the inputs of two transistors through center tap setup transformer TR1, which provides opposite polarity signals to the two transistor inputs. The collector terminals of both the transistors are connected to N terminals of center tap primary of the output transistor TR2. The power supply VCC is connected between the emitter terminals and the center tap of the primary of output transformer. Resistors R1 and R2 are used to provide the proper bias for the circuit. The load RL is connected across the secondary output transformer TR2. The turn ratio of the output transformer is chosen so as to match the load with the output impedance of the amplifier and therefore transform transfer maximum power. The quiescent currents of the two transistors which are equal in magnitude flows in opposite direction through each half primary of the transformer TR2 so that the saturation of the magnetic core. Circuit operation of Class A push-pull amplifier. When the base current of the transistor is being driven positive with respect to the quiescent point Q, the collector current increases, thus causing a decrease in collector potential relative to ground. At the same time, however, a reverse action takes place in the base circuit of the second transistor. That is, base current decreases, causing a drop in the collector current through consequent rise in the collector potential with respect to the ground. This means that the AC current flowing through the transformer primary winding is in the same direction. As IC1 increases, the current IC2 decreases. Hence, the name push-pull amplifier. The overall operation results in the AC voltage induced in the secondary of the output transformer, and thus AC power is delivered to the load. That the difference of the two collector current is illustrated in the figure. Distortion. In a view of the fact that the load in the secondary of the output transformer is proportional to the difference of collector currents, it follows that the harmonic content will be less than it is either of the collector current because of the cancellation effects. Thus, a push-pull arrangement yields much less distortion in the output. This is illustrated below. The base current IV1 and IV2 of the transistors Q1 and Q2 are respectively are expressed in IV1 is equals to IV sine omega t and IV2 is equals to IV sine omega t plus pi. Their collector currents are expressed as IC1 is equals to IC plus I1 sine omega t plus I2 sine 2 omega t plus I3 sine 3 omega t plus so on. And IC2 is equals to IC plus I1 sine omega t plus pi plus I2 sine 2 omega t plus 2 pi plus so on. And IC minus I2 is represented as 2I1 sine omega t plus 2I3 sine 3 omega t plus so on. The output voltage induced in the output transformer secondary being proportional to IC1 minus IC2. So, V out is equals to K of IC1 minus IC2. And we know that that is equals to 2K of I1 sine omega t plus I3 sine 3 omega t plus I5 sine 5 omega t plus so on. From the above equation for the output voltage, V out is the obvious that all even harmonics are eliminated. This conclusion was reached on the assumption that the two transistors are identical if their characteristics differ appreciably. The appearance of the even harmonic is